Good day, students. Welcome to Natural Science and Health Education 4. My name is Ananias Akweterera. I'm going to be your tutor for this subject this year. So you are all welcome and enjoy my presentation. What is the reason for giving this presentation? Is to lecture students on the most important content for the subject that is likely to be covered in the upcoming April, August, and November examination. So pay attention to my presentations and pick up as much as information as you can. So we have to look into Dalton atomic theory process. What does a Dalton atomic theory propose or say or suggest? It suggests that all matters consist of tiny particles called atoms, which cannot be broken down by anything. So it further suggested that all atoms of a particular element are the same. However, atoms of different elements are different. Take note of that. So when atoms combine, they form what you call compound atoms that were called compound. So that means compound is made from atom. When atom combines, they form what we call compounds. Atoms cannot be created or destroyed in a chemical reaction or chemical processes. Let us look into kinetic molecular theories in terms of solid. Because we have solid, we have liquid, we have gas. Now here we are looking specifically into solid. What does it say? Kinetic molecular theory. It says that solid have little space between particles. The particles are tightly packed together and they are very strong. However, become liquid or gas if the temperature rises. So let us look into building materials such as concrete, woods, corrugated ions, specifically looking into compressive and tensiles of those specific building materials, and also their molecular structures and bonding. Here we have to look into concrete, wood, and corrugated iron specifically. So what do they say about concrete? Concrete is a non-linear, non-elastic, brittle material. It is strong in compression and very weak in tension. It is a mixture of sand, cement, water, and aggregates. That is its composition, how it is made. So concrete increases in strength continuously from the day it is made or cast. How about wood? Wood is strong in tensions and compression, but can be weak in bending due to its fibrous structure. Wood is relatively good in fire as it chars, which provides the wood in the center of element with some protections allow the structure to retain some strength for the reasonable length. How about corrugated iron? This one has a variable tensile strength according to the types of the metal. For example, let's look into a stainless steel. It is stronger than aluminum and can stand up to more pressures at localized point at a panel. It also increases strength in the distance between corrugated grooves. The tighter together the grooves pattern of the panel, the stronger it is when standing up to pressure from a tree of branches. Pollution is a problem every day in our communities, in our environment, and human contribute also to what we call pollution. So what are the causes of pollution, specifically respiratory diseases? What are those ones that are caused by air pollution? They are asthma, bronchitis, allergies, emphysema, lung cancer, coughing, as well as shortness of breath. Now, how do we prevent air pollution within our areas, since air pollution is a problem to everyone and also within our community? What we do is we reduce the burning of wood and coal, since it contributes to the air pollution. This is a most contributions of air pollution on a daily basis, especially when people are burning wood when they're clearing land or farming, and this is a problem. So use public transport provisionally if you can, and reduce number of vehicles on the road. Reduce sulfur dioxide and carbon dioxide if you reduce burning of firewood and coal. So use vehicles which don't require fossil fuel or electric cars. Use unload petrol. Decrease amount of lead in atmosphere. Use catalytic converter on a car and in factory. This is a modern systems or ways of reducing air pollutions. Monitor emission from industry so that they comply with government regulations set to reduce pollution. Without education or knowledge, people they are likely not to implement what is said. So educate people on the danger of air pollution and how to prevent or avoid air pollution, and use possible solutions to avoid that. Let's look into chemicals versus hydrogen bonds. Let's look into these bonds. What are the difference? What does it say? Chemical bond in a water molecule is a strong bond between a hydrogen and an oxygen atom inside a molecule of water. A hydrogen bond is a weak bond between two water molecules. All right? The oxygen atom is in one water molecule, and the hydrogen atom in another water molecule are attracted to each other. They combine to form a compound. Let's look into a position time graph of three different sound waves, as is shown on the right hand side, with sound A, sound B, sound C. And we have to look into the structure for the property for the sound in terms of pitch and loudness for those three different sounds. Sound A and sound C. Sound A and B have the same amplitude, and therefore they would be equally loud. So the loudness will be the same as compared to C. Sound C has the greatest amplitude and would be the loudest of the three sounds. Sound B and C has the same frequency and will therefore have the same pitch. Let's look into calculations, because calculation is more important and it's also likely to come in our exam. So let's look into average speed. How do we calculate average speed? Sample question. An athlete is competing in a 400-meter race. The average speed of a sprinter who completed a 400-meter race in 53 seconds only. The formula for calculating average speed is distance divided by time. So time is given and distance is given, which is 400 meters. If you divide that, you get average speed of 7.55 meters per second. How about potential energy? What do we mean by potential energy? Potential energy of an object can be considered as stored energy, because if the object can retain or keep it until such time as it transfers it to another system or part of a system. For instance, the water in a hydroelectric dam is also a stored energy. It is gravitational potential energy as long as it is in the dam. If it's still in the dam, then it's called potential energy. Gravitational potential energy, how do we calculate that one? The gravitational potential energy of a kiloliter of water, which is given a mass of 1000 kg, in a dam relative to a turbine 100 meters below it. The gravitational potential is equal to mgh, which is a mass, gravitational force, which is 9.8 meter per second, and the height is 100 meter. You get the gravitational potential energy of 98000 joule. Sorry. Another sample calculation is work done. How do you calculate work done? For example, work done by a forklift that moves at 34 meters, carrying 1023 Newton of box across the warehouse floor. Work done is calculated with a formula of work done is equal to force times distance. Then you get the answer of 34.782 joule. Okay? Let's look into energy conversion processes. We have 5 energy conversion processes, namely solar energy, tidal energy, geothermal energy, wind energy, and hydroelectric energy. Solar energy, those are solar cell or photovoltaic cell, which has the ability to convert light energy into electrical energy. The energy in a solar cell can be stored for a short period so that they can provide energy at night, right? So about tidal energy. Is an electrical generator positioned at the mouth of a river that leads into the ocean and can harness the movement of water from ingoing and outgoing tide to make electrical energy. And this is also known as ocean tide electricity generator. All right. So how about geothermal energy? This is a pipes carrying water, which is placed under a hot or very hot rocks, which can create steam, and in such a way it also creates what you call geothermal energy. Hydroelectric energy is the movement of flowing water from a higher point to the lower point, and used to drive such a turbine in order to make electricity or to make such electric energy. Let's look into geographical north and magnetic north pole of the Earth. What are the difference? What are the similarities, if they have any? The magnetic north pole, it is where the Earth's magnetic field is perpendicular to the ground. The geographic north pole is the point on the surface of the Earth where lines of the Earth's axis of rotation meet the Earth's surface. That is very clear. Let's look into another sample calculation for the current in a certain circuit, which is considering the amount of charges equal to 45 current, which moves past a point in a second. Electric current is equal to charges passing a point. That is the formula. Current is equal to Q over T. Then when you calculate it, you get the current of 45 amps. That is how you calculate it. So let's look into this simple circuit given to us, because we have to use this one to calculate total resistance, because it's very important. Student must be able to calculate total resistance. How do you calculate it? You just add all the resistance together to get the total resistance. For example, resistance equal to resistance 1 plus resistance 2. Resistance 1 is 2, as is showing on in the graph, and the resistance 2 is equal to 1. Then you add them together, you get 3. Students must be able to draw a circuit when they are asked to do so in the examination. A sample diagram which is shown in this slide, it can be possible to ask a student indicate or draw a diagram, with an ammeter, voltmeter, closed circuit, and arrow that will indicate the directions of the conventional current. All those characters, they are shown in this circuit diagram given here. And that's how you draw it when you are being asked to do so in the examination. Using also a circuit diagram, one can also calculate resistance, currents, and other things. It's follow and some simple calculations that are following on next. Current of a bulb. Let's look into this simple example. Calculate the current the bulb is designed if it is used in a 12-volt circuit, and determine the resistance of the bulb's element. Now, first of all, you have to determine the current before you get the resistance. All right. So how do we calculate the current? Current is equal to power. Current is power, which is equal to current times voltage. Now, since we are looking for current, we have to make current as a subject of the formula. How do we do it? We say current is equal to power divided by voltage. Then you get the answer of 3 amps. Then from there you use 3 to calculate resistance, which means resistance is equal to volt over current. Then you get the answer of 4 amps. Now, determine also the effective resistance of the following circuit. First of all, you have to determine the resistance, which is resistance R1 plus R2. Then you get 50. From there, use the formula of 1 divided by R parallel is equal to 1 of R1 plus 1 over R2. When you substitute at the end of the day, you get R parallel is equal to 22.22. Then you have to look now for R series, which is R1 plus R2. Then we add 55 plus 22.2. Then you get the final answer for the effective resistance. Let's look into volume and the pressure of the gas. What does the difference implies here? What is the difference between volume and pressure, or the similarity? Using Boyle's law, also referred to Boyle's Marriott law, it is stated that the absolute pressure and volume of a given mass of a confined gas are inversely proportional if the pressure remains unchanged. Okay, within a closed system. Hence, or that's why, it states that the product of pressure and volume is a constant for a given mass of confined gas as long as the temperature stay the same. What are the properties of noble gas? Let's look into noble gas. A noble gas are found in a minute quantity in the atmosphere, right? So they are all odorless, which means they don't have odor, they don't have color, and they are also monatomic gases. Pardon. They are inert and do not react chemically. All right. This is because they do not readily form compounds with other elements. Noble gases are also called inert gases that we should know, right? Let's look into the difference between acid and alkali. What is the property of acid and alkali? Acids are liquids. They are solutions of compounds in water, in H2O, right? If concentrated, they are corrosive. Acid taste sour. They contain hydrogen ions. They usually react with metal to form salt. And they also turn universal indicators from green to red and have a pH less than 7. Because less than 7 pH, it means acidic. More than 7, it means alkali. 7, it means neutral, all right? So what about alkali? They feel soapy to touch. The pH is more than 7. They are soluble bases. They can burn the skin. They turn red litmus blue. They contain hydrogen ions, and they taste as well bitter. When it comes to periodic table, students, they must be able at least to complete certain given equations when it comes to the reactions which happens between acids and bases. For example, sodium hydroxide plus hydrochloric acid. When it reacts, it forms sodium chloride plus H2O, which is water. So a certain equation can be given with one sort of incomplete reaction, and you will be asked to complete the equation. So students must be able to complete those equations. So let's look into the use of carbon dioxide in real life. Carbon dioxide is used as a dry ice, in soda water, in baking soda, in fire extinguishers, as well as a cooling agent. Let's look into bonds. Covalent bonds of a single bond and double bond. How do they look like? What are the structures and similarities and differences? Single covalent bonds specifically occur when each atom shares one electron and attain a noble gas status. All right? It occurs when a hydrogen atom has one covalent electron only. When two hydrogen atoms collides, their covalence orbit overlap, and then the two molecules form a molecule, as is shown on the figure given, on the picture which is shown. Sorry. For example, hydrogen and chloride, they form a molecule, right? So a double covalent bonds, it involves two shared pairs of electrons. For example, oxygen gas, it has 6 valence electrons. So this double bond is, for example, between oxygen atom, which combine to form oxygen gas. Atoms shares 2 pairs of electrons with each other in order to have one octet. Are we together? So as you can see, single covalent bond and double covalent bond, their formation is totally different, right? Hydrogen chloride is a molecule, as you can see in the picture shown. And then oxygen atom is a double bond, as is shown. Take that note. So sample calculation, let's look into relative molecular mass of water, for example. How do we calculate it? Molecular mass of water, you just multiply the, you just add them together. Molecular mass of hydrogen, which is 1.01, you times with 2, because it's H2, and oxygen is 16.0. You combine, you get 18.02. Let's look into the force applied. For example, in a cylindrical container, if the pressure exerted by it is on a cement platform, which is 1,750 Pascal. If the contact area of the container with the platform is circular and has a diameter of 0.8 meter. How do you calculate this one? First, you have to determine the radius, right? Radius is equal to 0.8 meter. You divide by 2, you get 0.4 meter. Then with the radius, you can now determine the area. Area is equal to pi times r squared. The area is given is, the pi is 3.14 or 3.14. That's a standard pi. Time is 0.4, which is radius squared. Then you get the answer, which is 0.50 meters squared. Now, with that one, you can now determine the pressure. The force. How do you calculate it? Pressure is equal to force over area. Then you have to make force as a subject of the formula. Then force is equal to pressure times area. You multiply, you get 879.2 Newton. All right? Let's look into this example. Elena makes a longitudinal wave on a spring by making a complete vibration every 0.4 seconds, and the distance between two successive compression is 0.20 meter. So calculate the speed. How do you calculate that speed? 1 divided by t, which is 1 divided by time. All right? 1 divided by 0.4, you get the answer. Then from there, you determine the speed. Then you end up getting 0.5 meter per second. Another example, calculate relative atomic mass. If the mass is 12.011, no, pardon me, carbon relative atomic mass is 12.011. So what we have to look at, or we have to calculate, is the percentage. So determine the percentage occurrence of each of the isotopes if we assume that carbons only occur at 14 and 12. Assume that X percentage, this is a correction, X percentage, C is equal to 14, no, C is equal to 12, and Y is equal to 14. Y percentage is equal to 14. So that's a correction. You calculate, then you get the answer. Apology for this. The presentation cuts out the final answer, but that's the formula you have to use until you get the final answer. Just substitute through, then you get the final answer. The final answer should be 99 point something, right? What if lithium occurs as two isotopes in a proportions shown as lithium 6, which is 7%, and lithium 7, which is 93%? So calculate the average mass of the two isotopes. How do you do it? Mass of 100 atoms, you just multiply, right? You multiply each, for example, lithium, you multiply 6 by its percentage, 7 with its percentage. Then you divide them, then you get the average mass of the two isotopes, right? So let's look into also this another example. The electric fan uses 230 volts to 230 volts to 2000 watts. The cost of one electrical unit is 1.56 Namibian dollar. So calculate the number of units of electricity in kilowatts hour used when the fan is left on for 2 hours only. The cost of using the fan is 2 hours, right? So energy is equal to power times time period. You calculate, then you get the answer, which is 4 kWh. How is about the cost? Cost is number of unit. You times the cost per unit. Then you get 6.24 Namibian dollar. All right. Number of units. You times cost per unit. That is 4 times 1.56, which is a unit, which is a cost per unit, and then you get that answer. All right. So what about geographic north versus magnetic north pole of the Earth? The magnetic north pole, it is where the Earth magnetic field is perpendicular to the ground. The geographic north pole is the point on the surface of the Earth where lines of Earth axis of rotation meets the Earth's surface. All right. With that, we end our presentations. I hope it was useful, and students they get something, or they pick up the main point that I was presenting, which might help students to be able to answer certain questions in the upcoming exam. I wish you all the best, and have a nice day. Thank you.